first? You know first? How do I measure average hour of sleep? Okay, so okay. So what if here is? So what if we count here as 8 hours? As 8 hour. Here's 4. Yes, it is.
What would you say?
Not likely. Screw that. Screw that.
8?
Let's just say this is.
Okay. So, quick point, guys.
Hour.
Average hours of sleep per night. Now,
5.
with the enjoyment scale, like enjoyment of math, we know that positive means you like it.
4.
Negative means you don't like it. Obviously, the further you go, the more you like it. Now, average hours of sleep per night, what do I need to include on this axis?
Where each hour is like.
We call that a scale.
Like
right?
scale.
Yeah, no, it's okay. Perfect. We need to actually recognize, like, if I'm down here versus I'm up here, how many hours is this?
I don't know.
How many hours is that? And we know that most graphs that we look at actually have numbers on them. So when we're creating a scale, let's be consistent in the steps that we're going up, but also organized in the sense that we're not cramming everything together. So for average numbers of sleep per night, what do you think is a reasonable method to be going up by? Ones, yeah, sure. We can go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't think most of you get more than 10 hours of sleep per night. If you do, then you can just make your graph a little bit higher. But here we can actually create what we call it's not 5. We can create a scale to help organize our data and actually show where we are quantitatively. So what the actual value is, not just a like or a dislike. So this one we had a little bit more freedom in the sense that we could just show like, oh, I like this a lot, so I'm gonna be all the way over there. Here we actually have to think about where we fall on the axis system. I'm gonna come around in a second.
What it is?
Making it clear so you can see.
Make sure. Read our second one, or you guys just do all of them together? Where do we fall? Are we working over there?
Yeah.
So once again, like where would this, like what would this be? Lonnie. What would this be? Like 8 hours, 7 hours, 10 hours? What would we think here? 9 hours. So that means. Right? Alexa. So if we're at 9 hours up here,
Okay.
you're saying that you're probably what?
I'll say around.
6 hours.
I'll say around here.
See, that's the thing. Like maybe you think, well, I'm actually closer to 8, but I didn't know how high Lonnie was here, right? So having the scale is important for us to actually understand.
You sleep 4 hours?
Okay? So put a scale on there for me.
Maybe more than 4.
Maybe more than
How are you doing over here? You like math? Nice. Guys, we both over there. They should like math more.
You should only sleep 4.
Oh my God,
You should only sleep 4 hours.
Yeah, I
Good.
sleep like 5.5.
Not enough sleep. Definitely not enough sleep.
Okay, guys, so next one here, we're going to change our axis. Did everyone feel good with that? Or are you guys still finishing up? Okay, finish that one up. Pass the marker to Valeria. All right? You can do the next one, okay? So as Valeria is doing the next grid, or next axis system, which is enjoyment of milk chocolate. So how much do you like milk chocolate? And then our x-axis is how many hours you can go without looking at your phone. How many hours can you go without looking at your phone? And no, you can't go negative. You can't go negative time. How many hours can you go without looking at your phone?
Thanks.
So number of hours, guys, make sure we have an axis system for, or sorry, a scale for that x-axis.
Okay, weird. how long do we make this? The hour mark. How do we make this?
Maybe
What do we make here? Like a day?
a day.
Okay. 1 day. So that's 12 hours. 9? No, wait, half. 6? 6? No, 6. Wait, 5, 6.
Wait,
6.
you should do
6. 8. 18. Is this fair? Go first.
Just because you're asleep 7 hours? It's good. It's good. So if you can go 6 hours, I realistically said go for a day in this class.
Yeah, hour. I think it's bad.
5 hours.
Okay, yes.
Make sure we have 5 hours.
Maybe 30 minutes, Chelsea.
Think about what? So your thing is like being a little bit picky here, but you guys are a little bit picky. This is 1 hour here, right? 1 hour here. Is this just the same as this distance here? When we make our scale, and it's going to be easier when I give you grid paper and stuff too. We want to be consistent, make set increments that I get. That spacing is the same. It makes our life so much easier when we have nice.
Wait, what are you going to be doing for 6 hours? Wait, I want to check.
How are you doing here? Where's your sister? Oh, she did her own? 6 hours. Nice. No time at all? What's our scaling with this axis? And an hour and a half. Good. So, as I'm looking at your grids for this one, guys, I see a lot of people can spend an hour, at least an hour and a half of time not on their phone, which is perfect. Because this class is like an hour and a little bit. So that means there's no reason every day when you get into this class, you've just been on lunch, you were just on your phone all lunch period, you can put your phone away for an hour and a little bit, right? Right? You guys all showed me, you guys all told me you don't have to be on your phone for over an hour, or 2, or 3, or 4. So why don't we exercise that every day in this class? Okay, so we can see here, guys, what we're doing is we're looking at our personal connection, the relationship between different things in our lives. Our enjoyment for things and the number of hours we do something, or one thing about our life and something else about our life. Now, do you guys think there's any actual connection between the amount of the enjoyment of how much you like chocolate and how long you can go without looking at your phone? Do you think there's an actual connection between those two?
Very little.
Very little, probably none, right? So even though these two things are completely sort of separate from each other, completely two different things in your life that have no real connection, we can still mathematically represent the relationship. Now, when we go to look at, well, what is the connection, we might say, there is none. And if I were to put you guys all on this graph, we would have dots all over the place, right? There'd be no reason, there'd be no inkling that says, the more you like chocolate, the more time you can go without being on your phone. We know that's not the case. Because, or I know that's not the case by looking at all of your data and saying, well, it's all over the place. However, there is going to be connections between things that do have a relationship. And an example of that is, let's say, does anybody here work at a grocery store? Grocery store, anyone? No one works at a grocery store? That's a really popular job for students. But anyways, the temperature outside and the ice cream sales. What do you think happens as the temperature outside goes up? What do you think happens? To the
Ice cream sales go down.
The ice cream sales go up. So like we might not be perfect, but we know that as the temperature is increasing, my amount of sales will go up. And we see that even though it's not perfect, there's some sort of relationship going on there. It's what we call an increasing relationship. As we increase one variable, the other variable increases as well. Now, if I looked at, instead of ice cream sales, hot chocolate sales, this might exhibit a different type of relationship. As my temperature goes up, my sales for hot chocolate are going to decrease. And we call this, like Jada said, a decreasing relationship. As one variable goes up, the other one's going down. So, different types of relationships, as well as different types of functions, are really, like I said, the crux of what we're studying in this course. How things are related to each other. Now, in order to be successful at studying these functions and relationships, we need to still have strong algebraic skills. We need to still be able to use our calculators and evaluate numbers. We're going to be working with a lot of numbers, right? So although the concept behind all this sounds amazing, like, oh, we're seeing how things are connected and how mathematically we can represent those two things on axes and create equations and functions to help us guess how many hot chocolate sales I'm going to have when it's negative 20 degrees out. We still need to have the fundamental skills that you've developed in grade 9 and 10 to actually do the math behind the relationships that are going on. Does that make sense, guys?